Welcome to ERC Tipsnology. In this video, we will be learning the mesh analysis or branch current method on voltage and current sources and 5 resistors in series parallel circuit. So let's start. First, let's draw the circuit of a voltage source on the left side and a current source on the right side. Let's call this IS and VS, and we will put 5 resistors in between in series parallel named R1 to R5 with 300, 400, 500, 200, and 300 ohms and a voltage of 10 volts and 100 milliamperes current source. The first step in mesh analysis is to draw the loop inside the closed loop in the circuit. As you can see, we have 3 loops, one on the left, one in the middle, and one on the right. Now, the next step is to draw the arrowheads based on your proposed or assumed direction. As you can see, the first loop is clockwise, the second loop is clockwise, but the third loop is counterclockwise because I followed the direction of the current source. Let's name this as I1, I2, and I3. Now, let's look on loop I1 and we will get the following equation: 300 I1 plus 400 I1 minus the direction of I2 is opposite, so it's minus I2. We have to take note of that if the currents have different direction, it will be subtracted. And then, going through the loop, we have negative 10 volts, so minus 10 and then equals 0. Then we write it again, 300 I1 plus 400 multiply with I1, and we have plus and minus, and so that would be negative 400 I2. And this negative 10 will become positive 10 when you move it to the right side of the equation. And let's take the sum of 300 I1 and 400 I1. Factor out the I1, which is common to the two, minus 400 I2 equals 10. And we will get here 700 I1 minus 400 I2 equals 10. And that will be our equation number 1 for loop I1. After that, we can look on I2, and let's start from 500 I2 plus 200 I2, and I3 is in the same direction, so we will add it, plus I3, and then going counterclockwise 400 I2 minus the I1, which is in the opposite direction. And that's it, equals 0. Then we write here 500 I2 plus 200 I2 plus, so it will be plus 200 I3 plus 400 I2 plus and minus, so it will become minus 400 I1 equals 0. Then we have here the negative 400 I1. We put it here in the beginning. And then we will follow it with I2, which is 400, and another one, 200 and 500. Let's put them in a square. Or let's encircle them. And let's add all of these values. 500 plus 200 plus 400 multiply with the factored out I2 plus 200 I3. I arranged the equation so that I1, I2, and I3 will be in succession. So negative 400 I1 plus the sum of the two, or 5 plus 2 plus 4, that would be 1,100 I2. And we can also use the calculator to be sure. And then plus 200 I3, and that will be for our loop number I2. But we have to put equals 0 in the equation also. So I3 is equal to 100 milliamperes because the current source is already given. Therefore, the I3 will be equal to 100 milliamperes. And we can substitute this 100 milliamperes to the value of I3 in equation number 2. So I3 will also be converted here into amperes. So we got 0.1 ampere here. And we can substitute the 0.1 ampere here. Let's put equal 0 over there. And let's write it again. Minus 400 I1 plus 1100 I2 plus 200 multiplied with 0.1 ampere equals 0. And we got minus 400 I1 plus 1100 I2. And that will be 200 multiplied with 0.1, and we will get a value of 20 and then equals 0. And there you go, we got equation number 4. Now we can use equation 1 and equation 4 together in order to get the value of I1 and I2. By the way, we substitute here the value of I3 in the equation number 2. Let's just write it down over here that we substituted I3 is equal 0.1 to the equation of loop I2 or equation number 2, just to be clear. And this one will be our equation number 4. Now let's check it again. So as you can see, we have 4 equations. This is equation 3 and this would be equation number 4. This is equation number 1. And this will be equation number 2. Although not necessary, it's better to write it. Now we have the first equation, 700 I1 minus 400 I2 equals 10. That will be coming from equation number 1. And let's write also the last equation that we have created, but let's make this better by writing it again, minus 400 I1 plus 1100 I2, because it must be like the constant is on the right side of the equation. So I put positive 20 to the right, it becomes negative 20. And then let's write it over here, so that will be equal to minus 20 as our equation number 4. And of course, we already know the value of our I3. But anyway, let's use the calculator, scientific, mode 5, 1. And let's enter 700 equals minus 400 or negative 400 equals 10 equals negative 400 equals 1100 equals and minus 20 equals, and you will get the value of x, which is representing I1. So I1 will be equal to 4.918 multiplied by 10 to the power of negative 3 in amperes, and we may change it to milliamperes simply as 4.918 milliamperes. And the y will be for I2, which will be negative 0.016393 amperes. Let's move the decimal point to the right 3 times, and that would give us 16.393 milliamperes. And of course, we have the I3, which we already know as 100 milliamperes. Now that we got I1, I2, and I3, we can now get the IR1, IR2, IR3, IR4, and IR5. As you can see here, IR1 equals I1, IR3 equals I2, and IR5 equals I3, obviously. And we get the value of IR1 as 4.918, I2 becomes 16.393, 393, and IR5 will be equal to I3, that will be 100 milliamperes. Now for IR2 is the difference between I1 and I2, but we will be getting the bigger number here. But I think I forgot to put the negative on the I2, which is negative 0.016393. So it should be negative 16.393 milliamperes. And that will be subtracted with 4.918, and what will happen is negative 16 minus 4.918. Let's see the answer. Let's write it first. I2 is equal to negative 16.393 milliamperes minus I1, which is 4.918 milliamperes. Let me write it down here. And of course, we will use the calculator to do this. And because it's negative 16 minus 4, it's like adding two negative numbers. And let's see what will we get when we use this formula. So we got negative 21.311 milliamperes. And lastly, we get the IR4 as the sum of I2 plus I3 because they have the same direction, which is downward. And let me get the value of I2, which is equal to negative 16.393 milliamperes plus the I3, which is 100 milliamperes. So in effect, it's like we are subtracting the two, 100 minus 16.393. And let's see what will be the answer. 83.607 milliamperes. And there you go. We got all of the currents from IR1, which is the current on R1, IR2, current on R2, IR3, current on R3, IR4, current in R4, and IR5, which is current in R5. And from this, we may now calculate the voltages. Let's just call the voltages across each resistors as V1, although we can also call it VR1 up to VR5 or simply V5. So let's just use the simpler names of V1 up to V5, and we will just multiply the current with the resistance of each individual resistors. And so my formula here will be I1 R1, I2 R2, and so on up to I5 R5. Now substituting the values of I1, I2, I3, I4, and I5 on this equation will be like writing it either in milliamperes or in ampere. But let us write it all in milliamperes. Or as you can see here, when we multiply the milliamperes with the ohm, we will be getting millivolt, and expectedly it will be a huge or big number, maybe amounting to thousands of millivolts, and so we have to convert it to volts. So if we try to calculate the values of the V1 up to V5 and we got the values in thousands, we have to divide the millivolts values by 1000 in order to make it volts. And so let me write here the R5 before we calculate. Okay. So now we got all the values of the required calculations. So let's calculate it now, one by one. Multiplied with 300, we will get 1475.4 millivolts, but that will become 1.475 volts. And for V2, let me see. V2, let's multiply the two values. Negative 21.311 multiplied with 400. We got negative 8,524.4 millivolts, or this will become negative 8.5244 volts. And we have V3, of course, which will be multiplying the two values also for V3. 16.393 multiplied with 500. We got 8196.5 or 8.196.5 volt. And then we have V4. I4R4 will be equal to 83.607 multiplied with 200. We got 16721.4, or this is in millivolts, or we may say 16.7214 volts. And finally, we have V5, I5R5, 100 milliamperes multiplied with 300 ohms. We will get 30,000 millivolts, but in reality, it will just be converted to 30 volts. And so let's encircle our answer here with the first one, V1, V2, V3, V4, and V5. Also here, let's put the circle. And there you go. We have calculated all of the required voltages and currents in our series parallel circuit with 1 voltage source and 1 current source connected with 5 resistors in series parallel. So I hope you learned something today with regards to the calculations of currents and voltages using mesh analysis, or also called branch current method. If you will compare these answers with our previous videos, the answer will be the same. So thank you so much for watching the video. I hope you subscribe and support our channel. Have a nice day, everyone.